Most people approach AI research like a straight line. You ask a question, you get an answer, and you move on. But that approach quietly limits the quality of everything that follows. As introduced on the opening slide of the document, treating research as a one-pass interaction leads to surface-level outputs because there's no structure forcing depth, validation, or refinement. The result is predictable. You don't get intelligence, you get approximations that feel convincing but lack precision. The failure isn't random, it's structural. The cause and effect flow shown on slide 2 makes this explicit. A prompt goes in, based on incomplete or shallow context. The AI fills in the gaps using patterns, not verified reasoning. There's no feedback loop to challenge or refine the output. So what comes out is a mix of generic knowledge, repeated ideas, and subtle hallucinations. Over time, this creates a hidden cost, decisions built on information that was never truly validated. The real shift happens when you stop evaluating AI based on how fast it responds and start evaluating it based on how reliable the output is. The comparison on slide 3 shows two completely different operating models. Linear prompting relies on surface data and conversational guessing, which leads to high hallucination risk and generic results. Systematic research, on the other hand, is grounded in verified sources, structured extraction, and validation, which produces high-signal insights you can actually act on. That difference comes from how the process is designed. Instead of a straight line, the system becomes a loop. As illustrated on slide 4, research moves through 4 stages: source discovery, information extraction, advanced synthesis, and cross-verification. Each stage feeds the next, and then loops back to improve the system over time. This is where intelligence is created, not in a single prompt, but in the interaction between structured steps. Everything starts with the quality of your inputs. On slide 5, the focus is on moving beyond generic web search and feeding the system with verified, high-quality sources like reports, transcripts, and technical documents. These are stored in a centralized source vault, which acts as a controlled input layer. Instead of letting the AI pull from vague training patterns, you constrain it to work with specific, relevant data tied to your objective. Once you have the right inputs, the next step is extraction, but not summarization. Slide 6 emphasizes stripping away conversational filler and isolating what actually matters. This includes the underlying logic, the raw data points, and the constraints shaping that data. By forcing the system to work at this level, you remove ambiguity early and prevent the model from introducing noise later in the process. After extraction, the system moves into synthesis. This is where most people default back to summarizing, but that's not the goal. As shown on slide 7, synthesis is about combining isolated insights into something new. You take facts from one domain and interpret them through another lens. This cross-pollination creates frameworks and strategies that didn't exist in the original material, turning information into usable intelligence. But none of that matters without verification. Slide 8 makes this the non-negotiable step. Every synthesized insight must be checked against the original source. If it can't be traced back, it isn't reliable. This closes the feedback gap that exists in linear prompting and ensures that every output is grounded in something real, not just statistically likely. To push reliability even further, the system introduces redundancy. On slide 9, 2 independent models process the same source and generate their own interpretations. If they agree, confidence increases. If they don't, that disagreement becomes a signal to investigate. This double-blind approach reduces blind spots and forces the system to confront uncertainty instead of hiding it. When applied in real scenarios, the process becomes consistent regardless of domain. Slide 10 shows this clearly. Whether you're analyzing market data or diving into technical systems, the flow remains the same. Source selection, structured extraction, and synthesis into actionable outputs. The difference is that instead of ending with a summary, you end with a decision-ready insight or a concrete plan. There are still failure points, and they're predictable. Slide 11 highlights 3 of them. First, ignoring the source layer, which removes the foundation of reliability. Second, overprompting, which adds unnecessary complexity and confuses the model. Third, creating an echo chamber by relying on a single perspective. Each of these breaks the system by reintroducing noise where structure is supposed to exist. When the system is applied correctly, it scales naturally. As shown on slide 12, a single operator can run focused cycles daily, building compounding insight over time. At a team level, the same structure can be distributed across multiple people, creating a shared intelligence system. What starts as a process becomes an asset, something that improves with use and becomes difficult to replicate. The final step is simple, but it's where most people hesitate. Slide 13 makes it clear. Choose one source, run it through the full system, and experience the difference directly. Because the advantage isn't access to AI, it's precision in how you use it. When you control the process, you control the output. And that's what turns AI from a tool into a system you can rely on. Don't just watch this, run it. Pick one source today, a report, a transcript, a data set. Run it through the four-stage system: discovery, extraction, synthesis, verification. Then come back and tell me, what changed in the quality of your output? Because once you see the difference, you won't go back to guessing. If this changed how you think, like and subscribe, and I'll catch you on the next presentation.